Okay, good morning guys. Today we are going to discuss about point defects in solid. Now in earlier videos I have covered some topics: crystalline metamorphosis, solid unit cell and crystal systems, lattice points, and the types of cubic unit cells, packing efficiency and relation between radius and the edge length A. And we also covered the relation between the radius ratio and the coordination number, along with some numericals on density. Now we are going to discuss this topic, defects, which is very important NEET exam. Okay, now I have written few things to save some time. Defects are the actually deviation from the regular pattern of arrangement of constant particles. Deviation. Now defects are of two types. One is point defect and another one is line defect. So we are going to discuss only point defect. Now point defects actually is due to the defect around a constituent particle. This is around or due to around a point. Here point means some constant particles which may be ion or atom or molecule. Okay, point defects are of three types. One is Stichometric defect, and the second one is non-stichometric defect. Third one is impurity defect. Now stichometric defects are those point defects which arises in actually mainly in ionic solids, but they may occur in covalent solids also. And due to this stoichiometric defects, the stoichiometry of the solid does not change. Stoichiometry means, for example, NaCl. If we take NaCl, stoichiometry of NaCl is 1:1. Cation is 1 and anion is 1. This is the stoichiometry of NaCl. Now defect is present in NaCl due to some elevated temperature, but due to that defect some ions leave the vacant sites, some ion leave the crystal sites, but because of that defect the stoichiometry of the NaCl does not change from this 1:1. The stoichiometry remains same. If we take this calcium chloride as the example, then stoichiometry of calcium chloride is 1:2. Due to some stoichiometric defect, this stoichiometry of calcium chloride does not change. Okay, and the non-stoichiometric defects are those defects due to which the stoichiometry of the solid changes. Okay, impurity defect is due to the presence of some foreign ions. Foreign ions means, for example, if we consider NaCl as the crystal or solid, then during this crystallization process, if we add some barium chloride, for example, then this barium 2 plus ion can be present in the crystals of NaCl. So some foreign, this is the host ions, or these are the host ions, Na plus and Cl minus ion. And if strontium chloride is added, some amount of strontium chloride is added to NaCl in its crystallization process, then some of the barium ions will occupy the sites or positions of Na plus. So here the foreign ions is barium 2 plus ion. The process is called doping actually. We will discuss later on. Okay, now we will come to this stoichiometric defect, which does not cause any change in its stoichiometry of the solid. Before that, I have written a very important point. Due to any these defects, due to any kind of defect, actually, the electrical neutrality of the solid does not change. For example, in NaCl defects occur NaCl is a neutral solid, but after the defect NaCl will remain neutral. It will not carry any positive charge, or it will not carry negative charge. In the individual ions, they can carry positive or negative charge, but overall the electrical neutrality of the solid remains neutral. This is a very important point. Okay, now let us come to stoichiometric defect. Types of stoichiometric defect. Now very important point or type of stoichiometric defect is Schottky defect. Schottky defect, let me write some very important point of Schottky defect. Okay, when equal number of cations and anions leave the crystal from the lattice sites, from their lattice sites, such defects are called Schottky defects. Okay, let me draw some diagram here. Suppose this is the ionic solid, plus minus 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 plus minus. Now this cation, let me keep it as empty, because this will go out, and here this will be anion. This is cation, this is anion, this is cation. Let me keep this as vacant also. This is cation, this is anion, this is cation. Now what I have mentioned in the definition, equal number of cations and anions leave the crystal site, then such type of defect is called Schottky defect. So here one cation is vacant, here one anion is vacant. Now one cation, one anion, two cation, two anion. So this is nothing but Schottky defect. I forgot to write one important point. This Schottky defect is usually occur in ionic solid, Okay, now let us discuss some points about this Schottky defect. First point is such defects are usually occurred in those ionic solids in which there is small difference in the size of the cations and anions. This is very important. Cations and the anions, यानी जो आयनिक सॉलिड जिसमें केटाइन एंड एनाइन का साइज जो है उसमें ज़्यादा डिफरेंस नहीं होता है, वैसे ही आयनिक सॉलिड में ये डिफेक्ट ऑब्जर्व करते हैं. which means in those ionic solids whose coordination number is high, in those ionic solids whose coordination number is high. यानी second important point is second important point is in ionic solids having high coordination number. Now high coordination number means coordination number of 6 and 8 actually, 6 or 8 we can consider, because when the size of cation and anions are similar, or if the difference in size between that of difference in size of cation and anion is small, then the coordination number will be large for that ionic solid. So next important point is now when this cation and anion leave the crystal, density, some consequences का density means mass per unit volume of the solid. So since some ions leave the crystal, therefore mass per unit volume mass per unit volume will decrease, therefore density of the solid decreases due to Schottky defect. This is a very important point. Due to Schottky defect, density of the solid density of the solid decreases, since some ions leave the crystal, due to which mass per unit volume decreases. This is very important point. Now another important consequence of Schottky defect is, now some ions leave the crystal, due to which vacancy is created. Okay, vacancy created. Very important point. Vacancy is created. Now due to this vacancy, if some potential is applied, then this electric current is applied, then these ions will be able to move. Ionic solids are bad conductors actually, but when such defects arise, some vacant space is there, due to which ions can move. So electrical conductivity of the solid is also increased actually, since there is a vacancy, due to which the ions will be able to move. So next important point is electrical conductivity of the solid slightly increases, and the stability of the solid decreases, Now next point, let me write the examples. Means what are those ionic solids in which Schottky defect may occur? So we need to write the ionic solids of high coordination number, that is 6 or 8. So for 6 you can mention this NaCl, KCl, MgO, and for coordination number 8 we can mention cesium chloride, cesium bromide, ammonium chloride, etc. These are the solids or ionic solids in which Schottky defect may arise. And the second type of stoichiometric defect is, Frenkel defect. Frenkel defect. Now what is a Frenkel defect? Let me write some point. It is also called dislocation defect because some ions dislocate from its crystal site to void actually, which are called interstitial site. Okay, now when a smaller ion, usually in ionic solid the smaller ion is the cation, usually which ion? Cation, move from its lattice site to occupy interstitial site, which are called void also, then such type of defect is Frenkel defect. Okay, then such type of defect is called Frenkel defect. So the cation must be small in comparison to the anion, which means there is a large difference between the sizes of the cation and the anion. Large difference in the sizes of cations and the anions. That is, coordination number will be low. Low coordination number means coordination number 4. We can take the example of coordination number 4. Examples. Coordination number 4 solids, we can give zinc sulfide, AgI, AgBr, AgCl, etc. These are the ionic solids with coordination number 4. So let me draw here. Let me draw the example of AgI. This is Ag plus, this is iodide ion, this is Ag plus, this is iodide ion, Ag plus, this is iodide ion. This ion does not leave the crystal, it just dislocate from this crystal site to this vacant site, which are called void. This is Ag plus, this is I minus, this is Ag plus, this is I minus. Okay, this is again a vacant space. So due to this defect, vacancy is also created. Now let me write some consequences. What about the density of the solid? Mass per unit volume does not change, because since ions do not leave the crystal, they just dislocate from their lattice site to void. So density remains same. It is because no ions leave the crystal site, they just dislocate from one place to some nearby voids. Okay, and the next point is vacancy. Here also is created. Vacancy is created. This is the vacant site. Due to this vacancy, ions will be able to move. Therefore, electrical conductivity increases slightly. Okay, let me write some examples. Examples I have already written here. These are some points about Frenkel defects. There are two more types of Stichometry defects, which are vacancy defect and the dislocation defect or interstitial defect. So I'm not writing those defects here. Vacancy defect is those defect in which vacancy is created. That is a general term. And interstitial defect is those defect are those defects in which some ions or some molecule or some atoms occupy the void. So this is actually this is an interstitial defect, because ions or constant particles occupy the void here. And Schottky defect, if we see the Schottky defect, vacancy is created here also. Therefore Schottky defect is also an example of vacancy defect. Vacancy defect, and let me write their names only. Okay, third one is vacancy defect, and fourth one is interstitial defect. Now these two defects are actually general terms which may be applied to the covalent or ionic solid, mainly for covalent solids. So this defect arises in case of Schottky defect also, and this case or this defect is also arises from Frenkel defect. So I'm not writing some points of these two defects, because important one is only Frenkel and Schottky defect. For this video, let me finish here. In the next video, let me cover another topics of point defects, which are non-stichometric defect and impurity defect. Thank you for today. Please share this video to your colleagues, and please subscribe my channel so that I can get motivation or inspiration. Thank you.